Now we're going to prove that the absolute value of a is less than 1 and the absolute value of a plus c is less than 1, given that the absolute value of ax squared plus bx plus c is less than 1 for all x in minus 1, 1. Okay, given any x in this interval, we have this inequality. Okay, first we prove that c is less than 1. We can do that by just taking x equals 0. Okay, this is true for any x. In particular, for x equals 0, we have a times 0 plus b times 0 plus c in absolute value less than 1. So we have this first part. Next, we're going to prove that a plus c is less than 1, less or equal than 1. Okay, if we take x equals 1, we have a plus b plus c. It's going to be less than 1. For x equals 1. For x is minus 1, we have a minus b plus c less than 1. So to get the result here, we write this formula. This one gives us that a plus b minus c is between 1 and minus 1. Plus c. And the second one is going to give us a minus b plus c between 1 and minus 1. Adding these two, we get minus 2 less than 2a plus 2c less than 2. Dividing everything by 2, we get a plus c is bigger than minus 1 and less than 1. And this means that a plus c in absolute value is less than 1. Okay. And now we're going to prove that a squared plus b squared plus c squared is less or equal than 5. To do this one here, we need to remember how to get the squares of the sums. Okay, so we can rewrite a squared plus b squared plus c squared as 1/2 a plus b plus c squared plus a minus b plus c squared minus 2ac. If I do it correctly. Okay, so let's try and prove this one. Let's prove that this one is equal to this one. So I have 1/2. When I expand this one, I'm going to get a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ac. And this one is going to give me a squared plus b squared plus c squared minus 2ab plus 2ac minus 2bc. Okay, here I'm going to have this one twice. When I divide, I'll get this one. This one will go with this. This will go with this. And the AC, I'm going to have 4AC. It's going to go, when I divide by 2, it's going to go with this. Therefore, it's true. Okay. So I'm going to use this one to find an upper bound for this quantity here. So here I have a plus b plus c in absolute value is less than 1. Therefore, when I square, I have a plus b plus c squared is less than 1. And I have a minus b plus c squared is less than 1. And here I can, to get this less than, okay, I can rewrite this one. Instead of the minus, I'm going to add. So I do the absolute value. But this one doesn't need an absolute value because it is square. So I need the absolute value here. So I have, before I take this one, I keep this one in mind. So I have a squared plus b squared plus c squared is going to be less than 1/2 a plus b plus c squared plus a minus b plus c squared plus the absolute value of AC. Okay. Here I have this one is less than 1. So this one is less than 2. When I have 1/2, it's going to be less than 1. And the problem is coming from here, AC. How to find an upper bound. So we have C is less than 1. We have proved that one in the first part. Here. C is less than 1. We need the upper bound for A. So therefore we have A in absolute value is going to be a plus c minus c. And using the triangular inequality, we have this one is less than a plus c plus c. An absolute value. A plus c is 1, and the absolute value of 1 is less than 1, so that means 1 plus 1, and therefore a is less than 2. Okay? And therefore, okay, I need this 2 here. It's less than the half here plus 2. Sorry, I need this 2 here. So therefore, I have 1 plus 2 times 2. It's coming from here, the 2ac. It's 1 plus 4, which is 5. So therefore, I have a squared plus b squared plus c squared is less than 5. Okay? And that's what I needed to prove. This shows that I got my value here. I did this one very quickly, but all the ideas that we need for these problems, are clear here. Okay? The only exception that I did almost miss is these 2 here. Okay? The 2. So when I do the absolute value, these 2 are equal. When I add something positive, this one is going to be less, and used it here. And I had to find an upper bound for C. For A, I used the triangular inequality here. This is an advanced problem. This is an Olympiad problem, but it's explained here, and we have all the tools and all the steps are explained. They are not well organized, but you see everything is clear here. Okay, you want to work it out, do it yourself. Okay, and I think we did all we have to do. Okay, the only thing that we didn't explain, I did prove this one, and I think that's it. I think that's all we need to do. If you have any questions, comment, please share and subscribe. Thank you.